And for rabbitfish, 100% is pure and 75% is trinucleotides, but many is mononucleotides. So we can conclude here that rabbitfish is dominated by trinucleotides. So here we can see 17 SSR primers that already work in PCR, and rabbitfish have 9 primers. So 17 primers from milkfish and 9 from rabbitfish. And if we calculate from the first one, 57% of these sequence can be made for these primers, and 56% for rabbitfish can be made for primers. And this we make some kinds of notes for several kinds of sequence. Some have short flanking region, so we cannot make primers. Some have high delta G, and some have mononucleotide. Some have the same inserted sequence, so we cannot make primers for milkfish. So this is same. This also the rabbitfish. Some have mononucleotides, so some we cannot make the primers. So here, summary, we have around 17 milkfish SSR primers. Most of them can be amplified in high temperatures, 59 degrees Celsius. And also expected product size is from 100 until 450. And also this is same. And 9 rabbitfish SSR primers also can be amplified in these high temperatures. And also expected product size is near 100 until 450. And we make evaluation of these SSR primers. So based on this picture, we can see that lower temperatures, annealing temperatures, make smear bands, many smear bands in the chair. So we don't use low temperatures. Most of them is more than 55 degrees Celsius. And 100% of SSR primers can be amplified in 59 and 60 degrees Celsius. So here we amplified, we try to amplify SSR primers in milkfish like marine wild fish. This is very common in captured milkfish in my country. We call this male milkfish, but this local people call this man milkfish because it's very similar with, the morphology is very similar with milkfish, but you can see here the primers cannot be amplified. And rabbitfish SS primers don't reveal polymorphism. You can see these 2 primers. Also, this is also these 2 primers, 48 and 41, 42 and 44, 45 and 46, and 48. Most of them is not amplified. So we can conclude here that the first one, we have high percentage of positive clones, and the second one, we have also high percentage of clones containing SSR, and also we already success to amplify all the SSR primers. All can work in PCR. So here we really satisfied. So all the primers can be amplified, even though we don't find some kind of polymorphism. This question. So we can conclude here that step-diffidine coated magnetic spiration or magnetic spiral spiration techniques is quite effective way for SSR enrichments. You can see the percentage of clones, positive clones is quite high compared to Chiu et al. Using traditional techniques, only get 8% of DNA fragments. And then for technical experience, we suggest that we need to lower concentration of MSE1 than EcoR1 because the Eco R1 have more longer cutting side than MSE1. So if you use lower MSE1, the longer the size, the DNA size will be longer than if we use more concentration of MSE1. So we can say here that maybe marker-assisted selection is offer the advantage for accelerated selection of important traits. For example, fewer body muscle and better lipid deposition. And we already done this isolation and calculation of SSR fish and rabbitfish. And we hope the next study we can see some kinds of marker-assisted selection in these two fish. And some of that strategy is to make a linkage between phenotypes and genotype using a statistical analysis. So, based on the characterization of SSR, we can see that higher genucleated SSR, and some people they say that this genucleated SSR higher seepage repeat and also higher polymorphic. So maybe they have some kinds of possibilities that milkfish have higher polymorphism and rabbitfish. We can see here in the picture, they have some size. Both of them have few motifs. Milkfish have nucleotides, the same with nucleotides, and rabbitfish have more nucleotides types and less mononucleotides. And also ICTG motifs was found in milkfish. So ICTG motifs is commonly found in SSR in fish, based on liu. And this polymorphism, GT repeats, is also inside the tilapia prolactin 1 chain promoters, that this can influence tilapia adaptation into saline water. So, and then our finding is milkfish is not milkfish. We can see here this male milkfish is very similar to this milkfish, and so maybe later we cannot say that this is male milkfish because this is not male milkfish. So we suspect that this species, maybe the Latin name is Elops species, Elops sp, because we can provide here the evidence that all the SS parameters cannot be amplified. And even though in this study we cannot find the polymorphism, but however we found some interesting results here that no denucleated SSR motif in rabbitfish, and most of the SSR motifs are pure motifs, and male milkfish is not milkfish. And our conclusion here is we need more attention, genetic improvement in this both of the species, because so progressive genetic field improvement and development of new SSR in milkfish and rabbitfish. Need to do more for this marker or mass program. And then we already made 17 SSR primers of milkfish and 9 primers of rabbitfish, and also evaluated in both of fishes. But although our primers successfully amplified in PCR, the polymorphism was still not revealed for both of species. In the end, I will give my reference for my professor, also Ulasan, also my friends, Mike, that teach me and nurture me in the labs and help me to doing this work until I finish. And before I don't know about molecular biology, and I have really something feeling and good understanding, better understanding than before about this molecular biology. And thank you very much for all the thank you very much.
Maybe let me ask a question. I think that we were asking you